Okay, so we have seen that a file might have a different type, and that different type of file would be actually opened via different type of applications. For example, if we have a MP4 file and we open it using maybe MS Word, then we will see different type of boxes appearing on our file, and there's no useful information. Okay, so like a particular file must have a type and must have some attributes which actually provide sufficient information to a system and a user for maybe protection, for maybe access and different type of operations on the file. So this is a window which is showing that how actually what type of information is actually contained by a file over a Mac operating system. We can see name, we can see extension, we can see size, we can see date and time it was created, it was modified, and we can see also logs that if there is some log, and then we can see the privileges that how and who can actually access and write on these files. So after this we have some file operations also need to be considered, that what type of particular operations which are can be applied on a file. So I already told you that file, you consider a file as an abstract data type which has particular parameters need to be filled, right? As we have abstract type data type in different type of programming languages, we see Python, Java, we have abstract data types. So similarly here we have also file which is an abstract data type. Okay, and the operations on a file we can perform are create a file, we can write over a file, we can read our file, we can requestion within the file, we can requestion from one or maybe we can shift the contents from start to end and end to start, or also within a file, or maybe we can move file from one location to another location. We can also delete a file, we can also truncate the file. Truncate means we can break the file from one portion, maybe one half into as a one file and another half as another file. So for performing any operation over file, we have two system calls, or we can say that we have two functions which are necessary to call. The first function is open. Open means that when you bring your file from data structure of disk into the main memory, and after bringing into the main memory, we can perform several tasks on that file. We can write on that, we can read on from that, we can delete some portion, we can truncate that file. So all of these operations can be performed after you apply the open call. And once the open call is done, then the file is open, and you can see the different pointer. You can play with different pointers such as write pointer, such as read pointer, such as seek pointer. So we can also manipulate with these pointers, right? And once you close the file, which means that you move the file from main memory again to the data structure, and you permanently write over there. Whatever the changes you made, you just close with those changes. So these are two functions which are actually when you open a file and you close a file are being called, right? So we have different type of locks over the file. We have a shared lock, we have exclusive lock, we have mandatory and advisory lock. So an exclusive or write lock also we can say that give a process exclusive access for writing to the specific part of the file. While a shared lock is a read lock, we also call it as a read lock, prohibits any other process from requesting a write lock on the specific part of the file. Okay, and similarly we have also mandatory or advisory locks, which means that sometimes you open a file and you see that it is locked and you enable lock using this. So these are actually advisory locks, and some mandatory locks when we put explicit lock on over a file, means if you put a password protection or something like that. So these are the advisory and mandatory locks. So we have also locking procedures, type locking approaches for a file, and these are actually some extension we usually see in our daily life. You might know we have executable type bin com and exe files, right? Object files, source files, batch files. Batch files usually present in Unix or Linux systems, and also in Windows systems are also available, right? And we have text files, we have word processors, libraries, print views such as JPGs, PS, PDFs, and archives, which means that zip are compressed file system files, right? And also we have multimedia, in which movies and other file formats are available, okay, which contains both audio and video information of a file. So these are different file extensions, some of file extensions, and we have then access methods, right, of a file. We have sequential access. Sequential access means we can access one after another, right? For example, if you remember when you are writing on a file, right, we say that file dot next line, right? Which means you write on the next line of a file. So we always write on the next line. This is a kind of sequential file access, right? Which means that we always access a file. This is actually not right. This is about the access. Okay. So for example, if you are at current location and this location, and you want to access something here, then you have to go sequentially, right? You have to go sequentially to access this. If you want to go here, then you have to go sequentially to access this. This is like previous days we have tape recorders, right? If you remember, these tape recorders have reels over here, two reels, right? And these reels are actually connected like this, right? We have tape recorders in previous days, so that if you want to listen some song which is available here, then you have to wind it over here, all of this tape to this pulley for bringing this portion on the readable area. So similarly, this is a kind of sequential access where you can access a file in sequential way, okay. And the methods for sequential access is read next, write next, and reset, right? So if you want to read, then you go next, 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 next. If you want to write, then you go next, 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 next. It's like that. You cannot jump on a particular location. While we have another method is direct access. This is a fixed length logical records where you have blocks available, okay, of every writing of every data belonging to a file, and you switch or you shift to a particular block using direct access. For example, this is a file, and we might have but several blocks of a file, so you can write over here, you can access from here, you can access from here, you can access from here. A good example of this is if you have a movie running on your computer, and you can switch to any particular location by using timestamp or drag line, right? You can go to anywhere. So this is actually an example of direct access. So we mostly have the direct access, which is actually we locate to a particular block using the read and write pointers, okay. So a read pointer to a particular block, a write pointer to a particular block, okay. And you can also start reading and writing on that using the next parameter, right? And we have other access method also, which is actually which involves actually index, a table or maybe index, you can say. We have an index which actually tell us that where we have a particular file and its particular data, right? For example, this is file and this is data, then where this file and particular data is available on the main memory, we can access using the index method. So this is another approach. We have a sequential access, we have a direct access, we have also index access methods. So a good example is here given over here. that we have an index file which actually contains index of all the files and logical records. Once a file, once we want to access a file or maybe data related to a record, right? Then what will happen that we just point to that entry into the index file, and related information is actually fetched from the disk storage, right? So this is actually an index file which is managed, right? It's managed by operating system. So this is another approach. We have direct access, we have sequential access, and we have also access through the index. And then we have data structures. In data structure, we have for every file on our system, we must have a directory. This is actually the directory structure, that at least we have one directory for putting up all of our files. So even if you see the C drive, then it is actually a partition. It is actually a part of directory structure. You cannot put if you put something on that even desktop, it is also a directory. So make sure that every file on a system, even if you have organized it well or mismanaged, but they are put into some directories. So we have different type of directory structures. We have single level directory also. We have also multi-level directories. We have also three type of directories of a system. So in this picture, it is shown that these are actually directories of a system, and these are actually the files of the system. So we have data structure, different type of directory structures we have available. We have RAID, which means a redundant array of independent disks, and we have also partitions over our disk, and we give partitions some volume name, okay, and each volume actually creates some tables for accessing the stuff available in that. And so here we will see the directory structure. For example, if we have a disk here, right, we have a directory, and we have some number of files in that directory. We have another directory, and we have some files over here, and in this directory we have again some files over here. So this is a typical organization of a file system, okay, that you have always files inside the directory. It never happens that you have files over here, right, without any directory. So this never happens. You have always files inside the directory. So operations performed on a directory. Previously we have seen operations performed on a file, which was read, write, and some other operations. While here we have operations on directory also. We can search in a directory, we can search for a file in a directory, we can create a file inside a directory, we can delete a file from a directory, we can list a directory, we can rename a directory, we can remove a directory, we can traverse through the file system using directories of a system. So there are several operations which can be performed on the directories of your system. So directory organizations, we have different type of groupings available. We have single level directory, we have multi-level or maybe double level directory, two level directory, and then we have also tree structures. So in single level directory we have we can see we have single directories, one directories, and we have corresponding files inside that directory. So the problem here is the naming and the grouping. We cannot have multiple names of a directory, the same names of two directories. For example, if I want to name another directory as A, then I cannot give a name to that directory because this is a single level directory. And so with the naming issues, there are also grouping issues there, that if you want to combine two directories, then how you can do this. So to resolve this issue, we have again a two-level directory. Now we can see that we can have same names here. Here we can see that we have same name in all of all of users. We have a directory in all users, and we have different type of files for all users inside the A directory. And so we have resolved the grouping issue, we have resolved the naming issue, but still the efficiency of this grouping is not good, because we can have only one user having only A, while if we want to add another A directory for this user 1, then we cannot do. We are still limited in grouping, right? In grouping, okay. And we have path name. Yes, for example, if you have user 1 and A and maybe abc.text, then this is actually the path of file, okay, which means that user 1 A and some file over here. Can have the same file name for different users. Yes, we can have the same file for different users, and efficient searching, while grouping capability is still limited in the 2-level directory. Then we have a tree structured directory. Now here we have resolved the grouping issue, okay. We can have multiple files, we can have multiple directories inside one directory. We can have again multiple directories. Inside those directories we have nested directories and files, and again even in a directory we can have also files and directories. This is also possible. So the tree structure is the most popular structure, which actually resolve many issues like grouping and searching. Searching is also efficient inside the tree. We know popular searching algorithm, tree search, right? Tree search algorithm, right? And we have also sufficient grouping capabilities, and the directories provides efficient file path, right? We have also proper path protocols are also available for this type of searching, for this type of directory structure. So I suggest you to see the tree search for the directories, and also do some research on that and come up with some algorithms, the latest algorithm of the tree search, right? Yeah. Find further, find and for this algorithm, right? And see it's working, right? How it works. So we have some other things to do with this directory structure. As we know, in Linux or UNIX systems, we have different commands to manipulate with this directory structure. For example, if we say rm, then this means that remove directory actually, and mk or maybe mkdir. These two are variations of making a directory, and this is actually when you are removing a directory, wherever you are, you remove the directory available over here, right? For example, if I say that if my path is maybe C and ABC, or maybe D and ABC, and I say remove 1, then it means, when I hit enter, then it means that inside the ABC directory there is a one name directory. I am removing that directory. If I say on the same path, if I say ABC and my pointer is here, right, and I say mk1, then it means I am making a directory named 1. This are also the variation of this command is also mkdir, the complete command. However, you can also use mk for that. And if you are in the mail and you create a count directory, then it will be available inside the mail directory, okay. While deleting a directory, actually delete entire subdirectories and all the files inside the directory. For example, if this might have some files, this might have some files, this might have some files. So every directory might have some files. And if I delete this mail directory, then I will delete all of the files inside the directory. We have also mounting file systems, right? For example, in the systems, Windows systems, this mounting is automatically done, and whenever you plug in a USB, that USB is actually mounted over your file system at some particular location, right? For example, sometimes it is there are some reserved locations where this mounting is done, right? And sometimes even you create your own folders to mount a particular file system over your disk or over your system. In Linux systems, we mount this manually, and in Windows and Mac systems, this is actually mounted by default, by its own. Okay, so for example, if we have this directory structure, right, of a drive, maybe we can say that, let's say this is a USB drive, right, and this is your Windows, right, and you want to mount this over here, right, then what will happen, that you will this will be look like this, that the user location you have mounted this new USB, okay, and some folder on your tree structure. On your tree structure, you mounted a new file system, right? The example is that, for example, if your Windows is NTFS format, right, and if your operating system is actually installed on NTFS format, and you load the FAT32 partition, FAT32 USB, then this is a different file system and this is a different file system. So these two file systems, inside the NTFS, you should mount actually the FAT32. So for mounting, you have a particular location, and you actually call the protocols on this location for mounting. Okay, call the system protocols on this location for mounting this. Okay, and then we have protection also. We have different type of protections. We have read, write, and execute, append, and delete. These are different protection that someone can read, or someone can write, or someone can execute, or maybe append or delete or list these files. Even you can protect your files from being listed in an uncontrolled user space. Okay, so protection, we have different type of access lists for different type of groups. For example, the owner access we have represented by 7, which means read, write, and execute. Okay, the owner can read, write, and execute. Also, we have group access 6, which means that we can only read, write, but not execute. This is actually the binary representation of 6, and this is binary representation of 7. So that's why we use 7. Okay, and for the public access, we only give executable. For example, if you give everybody's read-write access, then you use chmod 777, right? But if you want to give them particular only privileges, then you will do chmod maybe 761, right? This meant that owner can read, write, and execute, while the group can only access this, can only read this, can only write this, but cannot execute this, while the public, everybody else can only execute this, but while they cannot read, they cannot write on this one. Okay, so these are actually some protections which are provided by Unix systems, right? Unix or Linux system, right? And on the Windows, you can see this like that. You have you just right click and go to the property of a file and you see all of the permissions here, right? You see all of the permissions here. All the permissions are available over here, and I think you can edit them using this. I'm not a Windows user, but I believe it's if you go to the advanced, oh sorry, this here is if you want to change the permission for guest or for a particular user, you can do this by clicking this edit button. Okay, so you select a user from here and you edit, and then you can edit these permissions accordingly. This was actually Windows. On the Unix system, you can see these permissions as here: read only, and read write execute. Here, read write and read. These are actually operations performed under different time, right? And here also read write execute. So these are actually different operations performed on a particular file. So this is the end of chapter, and we conclude with this course, operating system. I'm Dr. Rahil. I was teaching operating system as Sukkur IBA during the spring semester of 2020. I hope this has helped you to understand some basic working of an operating system and all of its components, file systems, and memory management and virtualization and file systems, everything. We have learned CPU management, CPU scheduling. All of these concepts were very basic, were very primary concepts for understanding the working of an operating system, and this was actually uh, the core subject of computer science in our university. So I hope you pay proper attention to this subject, and if you have any concerns, we can discuss them in our next online class. Thank you so much.